This is a tutorial to help introduce the disease transmission investigation. Our objectives are to answer these two questions: how do infectious diseases spread, and which variables impact disease transmission? I'm going to walk you through part of the procedure and quantitative data collection. So on slide 4, there is a link there, and this is the simulation we'll be using. We will also be collecting data and making a graph in Google Sheets. So when you take a look at your data collection, it will look like this. And you'll notice on the bottom that there are two different tabs. There's medium and high. We're going to be collecting data for 2 fictitious diseases under medium population density and high population density. When we do that, we want to look for these 4 pieces of information: the death toll, sick days per capita, the day immunity was reached at its highest level, and the day contagiousness was at its highest level. So you have a procedure on slide 5. It says to start, reset the animation by clicking the green reset button on the upper left-hand portion of the screen, which is here. Hit the gray presets to return to the original settings. In order to complete the relatively virulent, to compare the relatively virulent diseases, the Red Death, to the less virulent disease, influenza, you will set the simulation for Red Death at medium population density and population mixing. So we're going to choose Red Death. Population is medium. Population mixing is medium. Run the simulation. Now we want to collect the data. So we're looking for the death toll. Some of the data will be on the right-hand side. Some of it will be on the graph on the left. The death toll is listed here at 116. We're also looking for sick days per capita. So we have sick days and sick days per capita. Per capita was 9.8. So I'm going to copy it just like it was. Now we want to find the day immunity reached its highest level. And that is going to be in this graph. So we see using the key that the blue line is immune. So we want to find out where it levels off. So here, I see at day 35, we have 473 immune. I can see if that's the highest level by looking at day 100. At day 100, there is still 473. So that is the highest amount, and that was reached on day 35. I also want to find the day contagiousness was at its highest level. So I'm going to use the key again. So the red line was contagious, and find the peak. So at day 12, it was at 437. Day 3 was 429. Day 13 was 435. So day 12 was when it was at its highest. Now I want to do the same thing with influenza. So the instructions say to reset. So I'm going to do the same thing I did in the beginning, is reset it. Run influenza at medium and medium population mixing. I'm going to run the simulation and repeat those steps and record my data in the same way. Once you have completed your influenza data, you're going to switch to the high population mixing and follow the same procedure. So you're going to repeat the same steps. So reset, choose Red Death, high population mixing, high population density. So I would like you to make a prediction as to what you think the difference will be between high population mixing and low population mixing. Okay, as you're working on this, make sure you ask questions if you need help, and good luck.